This is free response question number 2 on the 2019 instance of the AP Calc BC exam, the free response question part of the exam. Okay, this is a polar curve question. This from the past 10 years. I scrolled through the past 10 years of FRQs. There was like only 2 questions on polar curves. So the probability that it appears in the most recent years is not very high, but let's go over it in case you want the practice for it, okay? This one, a calculator is allowed and is probably needed to do some of the computations, okay? So let S be the region bounded by the graph of the polar curve. R of theta is this guy. Theta is between 0 and square root pi as shown in the figure above. Find the area of S. So we have to remember how the formula to find area of a polar curve is half integral from the limits of r squared d theta. Half r squared d theta. Okay, so our r is right here. Limits of integration are 0 to square root of pi. Okay, so the setup is really easy. It's just, as I was saying, half integral from 0 to square root pi, r squared d theta. You would have to plug this into the calculator. Okay, so like half f int of this guy with respect to x, or whatever variable, from 0 to square root of pi. And if you plug this in, you should get 3.5343, something like that. I would keep at the bare minimum 3 decimal places. Okay, so here I gave 4. Okay, part B, what is the average distance from the origin to a point on the polar curve, that guy, for theta is between 0 and square root pi? How do we interpret average distance from the origin? Did we learn anything about that? Not explicitly, but remember R is the distance from the origin, how much radially outward you go. So this is just asking the average value of R on this interval. The average value of a function, that's just 1 over the limits of integration, the interval, length of the interval, integral from 0 to square root pi of the function. Okay, put this into the calculator. You should get 1.5799. I would keep, again, at least 3 decimal places, so that would be rounding, 1.58, which the scoring guidelines accept, or this should be fine as well. By the way, let me go over the scoring guidelines for the first one. This is all public information, so you can look this up on the College Board website. The integral is 1 point. The answer is 1 point. Okay? The integral is 1 point here. Answer is 1 point. Okay? Part C. There is a line through the origin with positive slope that divides the region S into 2 regions with equal areas. Write but do not solve an equation involving 1 or more integrals whose solution gives the value of m. Okay, so this is just saying there's some line that splits this area in half, okay? We know how to represent a line through the origin in a linear line through the origin in polar coordinates. How to do that? That's theta equals something. Remember that? So that's what that line is. In rectangular coordinates or Cartesian coordinates, that's y equals mx. You might be more familiar with that. M is that slope. Y equals mx. Okay? So let's combine these 2 pieces of information. Y equals mx, and we know that tangent theta is y over x. We want to write this line, as I was saying, as theta equals something in polar form, polar coordinates, okay? So m is equal to y over x. Y over x is tangent theta, okay? So theta is arctangent m. This is the line, equation of the line in polar coordinates. This is in linear or Cartesian or rectangular coordinates. This is in polar coordinates right here, okay? So we can set up the integral. It's half r squared d theta, right? But from 0 to this point, half this line, which cuts it in half. So from 0 to this point, or this theta, because the limits are in theta, right? Okay, equals half of what we had up here. Exact same thing right there, okay? You can do r squared or r of theta. That's what the scoring guidelines do. I think this should be fine. Or you can even plug in what r is, which is right here, okay? I feel like this should be acceptable, okay? All right, part D, this is probably the more challenging one for most people. For k is greater than 0, let a of k be the area of the portion of the region S that is also inside the circle r equals k cosine theta. Find the limit as k approaches infinity, a of k. What in the world is this asking? Okay, so how does this r equals k cosine theta look? How does r equals cosine theta look? Hopefully you remember that. That's the circle that's offset to the side over here. Okay? So that's what I drew over here. That's what r equals k cosine theta looks like. Okay? So you can imagine as k approaches infinity, this will keep getting stretched, right? So the radius of the circle will keep getting bigger. Just imagine I'm pulling this, but you have to keep the circular shape. So the circle is getting bigger, bigger, bigger. And as we go to infinity, this will cover the whole Q1 and Q4, quadrant 1, quadrant 4. So as k approaches infinity, r equals k cosine theta would capture all the points in here and here. So all the points to the right of the y-axis. Okay? So now let's look here. Everything on the right-hand side of the y-axis. So we just want to, because A of k is the intersection of that circle and this region here, right? So as I said, capture everything here as we stretch that, right? So we just want this region over here. We cut out this small portion over here that's to the left of the y-axis, okay? So we just need to integrate from here to there. What are the limits of integration though? You can, since a calculator is allowed, you can just graph this and trace the graph to find out the limits of integration. Or let's be a little smarter. This is to the right of the y-axis, right? So we can, since we're starting from 0, we're going to square root of pi. We can probably make a good guess that will, first of all, we're going to start from 0, but we go only up to pi over 2. Pi over 2 is the positive y, right? So right there is probably pi over 2. You can confirm with your graphing calculator, okay? So the integral a of k equals half integral from 0 to pi over 2 r squared d theta. R is the function that they gave us. Plug this into your calculator, you should get 3.324. So the trick to this problem was knowing how this curve looks. R equals k cosine theta looks like this. And as we stretch k to infinity, we expand it. You can imagine this circular region keeps getting bigger, right? It'll include everything to the right of the y-axis. And that's how we do this one, okay? That's it for this problem. Hopefully it was helpful. Please give it a like, this video a like if it was. And hopefully I see you in another video as well. Bye.